And so we've already talked about combustion reactions. And the generic equation for this, for a combustion reaction, is this. And you'll notice that I have X and Y on here. Why do I have X and Y on there? Because there could be thousands of combinations there. Also, what I could have is not only CX, Y, but I could also add an oxygen on there. And I think we did that yesterday in one of the examples. But if I put in C6H12O6, I have a hydrocarbon, and this is C6H12O6 is what? Glucose, very good. But acetate is also something that could fall into there. So 2, 3, and 2. So there's another combination. So with this combination, the X, Y, and Z, when I react it with oxygen in a combustion, what does combustion mean? Burn, baby, burn. Yeah. So this is all different kinds of hydrocarbons. So you've got your methane, your propane, your octane, your sugars, lots of things. When it reacts with oxygen, its products are these, carbon dioxide and water, every single time. So today we're going to start predicting products. So when you see something that has only carbon and a hydrogen reacting with oxygen, what are your products going to be? Same stuff you're breathing out. So if you breathe into your hand, you might feel a little moisture on it. That's the water vapor. And one of the products that we breathe out is carbon dioxide. So anytime you see that carbon, hydrogen, and sometimes oxygen combination, automatically write water and carbon dioxide. These are the hardest to balance, not going to lie, but there's only 3 elements. And what was the rules for balancing this? Who should we start with? The water, very good. Start with the water, yeah. So you start with the water, and again, make that an even value, right? So if you're balancing it, you say, oh, a 3 or a 5 or a 7 would work great here because you have a number over there that would represent that. Just double it. And then start with this first, and of course save the oxygen for last. Okay. So we've already done these types of reactions. The only thing I didn't tell you is that the products for these are the same every single time, which kind of makes it not very exciting. Okay, and we'll do some practice here in a moment. The next type of reaction, and this just goes over how all those take place. The next type of reaction is called a synthesis reaction. And once you think about it, it's like, really? We're doing this? Yeah. So what I'm doing is I'm taking A and B and putting it together and making AB. Yeah. So like if I take sodium and chlorine and put it together, what am I going to make? Yeah, sodium chloride. Now here's the kicker. Make sure that we're balancing, and these will all be ionic. Okay. So what's the charge on sodium? +1. Charge on chlorine? -1. Why did I put a 2 there? And it ends in I and E. So this is what we're producing, but you can look at it and go, sodium and chloride. Oh yeah, I know that, sodium chloride. But then we go and balance this out, and then we're done. Okay. So today I'm giving you the things that we're starting with. You're going to predict the products. But with the synthesis reaction, that's the basic equation. You have 2 things, put them together, balance charges. Okay. So on the flip side, if we have a synthesis reaction, we can also have what's called a decomposition reaction. A decomposition reaction. What do you think happens in a decomposition reaction? Yeah, it goes the other way. So you start with a compound and you break it apart. So we start with a compound and then you break it apart into its elements. So I like using this one. If I have water and I want to decompose water, and you can. Don't think that when you decompose something that everything turns into like rubbish. And I like this statement here. Of the names, the 3 types I like, you can call it a desynthesis, a decombination, or deconstruction. I like decomposition. And I put on here, Mozart composed until the age of 35. After that, he decomposed. Terrible chemistry jokes. But looking at water, what would that break down into? Hydrogen and oxygen. And then we go and balance that out. Okay? So you break it down into its elements. So in this case, since there's already 2 hydrogen, I need 2 oxygen. Boom, and done. Okay. So today's stuff is pretty straightforward. Go ahead. What? Now we're going to do some examples. I put the 2 here because it ends in gen. If it ends in gen or INE, it should be diatomic. Okay. And how many different elements are like that? 7. 7. That's it. So say it to yourself, like, and the good news, it's all only the 52 that we know. So chlorine, bromine, iodine, hydrogen, nitrogen, oxygen. Okay. So don't stress yourself out. It's easier than you think if you just slow down for a second. All right. So yeah. Yeah, well, we're going to do some examples here. So let's look at, did I give you some practice? Maybe, oh, I know what it is. It's on, yeah, that's it. So go to the homework, number 3, I believe it is. Yeah, let's look at those. Okay, so I'm going to do the examples first, and then these are part of your homework. So like 1 through 4 is part of your homework, but let's do the example. I'll do the examples for each one. And then, so on the front side, I tell you what it is. So here's combustion. And then here in the middle is synthesis. And then down here is decomposition. So I'm telling you what it is. Then on the next page, they're all mixed up. Isn't that cool? So here's what I want you to do. And I didn't put a line here. I want you to tell me what kind of reaction each one is. Because on the test, you'll get to do that. So what is 13? Let's start right there. Combustion. What's 14? Synthesis. What's 15? Synthesis. What's 16? Decomposition. Here's how you know. Because you write down and you memorize this equation. Yeah, more of that memorization stuff. What did I just write? Combustion. That's synthesis. So I'd write that at the top of the page. And then going the other way. There you go. So how many things did I start with in 16? 1. How many things did I start with here? 2. What did I start with here? One of those. That's the other one. That's how we know. All right. Here's the crazy thing. Chemistry's not hard. You just make it hard. Right? It's not hard. I promise. I promise. All right, so let's look at the examples here. All right, so example number 1. Ah, look, there's glucose. Now, you don't need to know what glucose is. That's for biology. What are my products? Let's start there. That is not a synthesis.
Carbon dioxide and water.
All right, now listen. Guys, shh. Here's how you figure it out. How many different elements are in this? With a synthesis, you'll have 1 kind of element here, 1 kind of element there. Also, you have carbon and hydrogen and oxygen. So, what are the products again?
Carbon dioxide and water.
There you go. Or HOH, that'll work. That'll be fine. Okay. Now, I recommend that whenever working these out, do an inventory because the combustion ones are brutal. But the nice thing is there's only 3 elements. Okay. So let's start off with how many carbon on the left? 6. How many hydrogen? 12. How many oxygen? 8. Okay. No big deal. On the other side, we have 1 carbon, 2 hydrogen, and 3 oxygen. That'll be the same way every time, starting off. Okay. What should we start with? Every single time, water. And how can we get a good number there? A 6. Why'd you pick 6? Because we need 12, right? And 6 is a good number. Why? It's even. Okay, it's even. So now we have our hydrogens good. How many oxygens do we now have? Plus. Good. All right. So since the hydrogens are good, we don't have to do anything to this carbon over here. So what do we do next? Put a 6 in front of the carbon dioxide. Good. So that'll give us our 6 carbon, which we have 6 on this side. How many total oxygen do we now have? 18. So again, 6 times 2 is 12, plus 6 times 1, 18. Okay. So my carbons look good. My oxygen, I'll need 18, but keep in mind, there's some oxygens over here. So what do? I'd say, okay, well, since there's 6 over here and I need 18, I need to do 18 minus 6, which is what? 12. And then 12 divided by 2, 6. Okay. Now, what is glucose? Is that a sugar? Yeah. Sugar's the devil. 6, 6, 6.
What just happened?
Huh? That's the way what? No, it's just the way it works for glucose. No, that's the way it is for glucose. But it's a good joke. All right, try this one on your own. It is the same, except instead of starting with this, I start with oxygen. Remember the and or the plus sign just means and. For the combustion reactions, yes. That's for combustion reactions. For combustion. How do you know you have a combustion? You have carbon, hydrogen, sometimes oxygen, reacting with oxygen gas. So what should I have in front of the water? Huh? H? Ooh, a 23. 46. 23 is a good number, but it's an odd number. So double it. Okay. So if you see a 23, go, that's a good number, but double it, because 23 is going to cause me to go crazy here. So what is that, 92? And how many oxygen?
48.
48. So 46 times 1 plus 2. All right, so how do we get 92 hydrogens on the left side? Put a 2. Now, I promise I won't ever go over triple digits on the coefficients. Yeah, and somebody asked, so you promise not to go over to 999? I promise there will never be a 999. Now, 998, that's okay. All right, so how many hydrogen or carbon do we now have? 44, good. How do I get 44 on the right? 44. Yeah, whatever number you want to put there, odd or even, not a problem because we have an even. Yeah. So now how many hydrogen do I have? I'm sorry, how many oxygen?
136.
136. So 44 times 2 is 88. And then 46. Okay. So just adding them up. Okay. Is that 136? 134. Sorry about that. Okay. Now, let me ask you, are there any oxygens in this hydrocarbon? No. So the 134 is strictly for this oxygen here. So what's 1/2 of 134? What is it? 67? That I like. I hope it's not 66. Yeah, 134. No, I didn't.
He said 136, and then he changed it to 134, and he said, "Oh, whoops."
There we go. All right, so everybody good with combustion reactions? What are the products? Carbon dioxide and water. Same thing you breathe out. All right? Synthesis.
Oh my gosh, it's not working.
Okay. When you work out a synthesis problem, do not copy subscripts. Everybody hear that? When doing a synthesis reaction, do not copy subscripts. Do this. Write one of each. Why would we want to do that? Because we have a metal with a non-metal and we want to balance charges. The only time you're ever allowed to copy subscripts is when it's a polyatomic. I'm not going to give you a polyatomic in synthesis. Tomorrow, I'll give you polyatomics. Today, no. So, what is the charge on zinc? +2, good. And you get that from the periodic table. What's the charge on nitrogen all by itself? -3, good. It's in 5. So, we need how many nitrogens? 2. How many zincs? 3. Now, keep in mind, that 2 is not there because of that 2. The 2 on the right for nitrogen is there because of the charges. Why is this 2 there? Because it's nitrogen. Okay. Know the difference, guys. Okay. Again, we don't carry subscripts. Even though a lot of times the charges will dictate that we need 2 of those, we don't carry them. Let the charges, and always do the charges above. It's going to keep you from doing something silly. I didn't finish it. My bad. Sorry about that. Yeah, let's finish that. Here, let's get that out of it. My bad. Yeah, you always have to balance. Sorry about that. So, the nitrogen is good, right?
Yeah.
So, what do I need to do to the zinc? Put a 3. Sorry about that. Good call. Number 4. Okay. How do I write the product here? Always write what first? Metal. Always write the metal first. So the aluminum goes first. So sometimes don't freak out because, again, the plus sign just means and. So I have aluminum and chlorine, or I have chlorine and aluminum. But when they get together and form a compound, we always write the metal first. And then we'll put the chlorine here. This would be a really bad time to bring the subscript over because it won't be a 2. What's the charge on aluminum? And the charge on chlorine? So how many do we need? 3 of those. Okay. So you bring, so this does not exist. Bad. No such critter. We do not have a polyatomic as Cl2. We do not have a polyatomic as Cl2. The only time you use parentheses is to show more than one polyatomic. So today, you should not have parentheses. Okay. The reason why I said that is because that is what has happened in the past. All right, so we have our charges balanced. So how do we balance this out? How many chlorines? How many chlorines? How can I get the same number? Put a 3 there and a 2 there. Okay. So now my chlorines are good. So balance the aluminum, put a 2 there. Can I simplify that? And if you need to do inventory, do the inventory. Okay. Let's go the other way. Let's break it down. Okay. So decomposition. How do you know it's a decomposition? You only have one thing on the left. And that will be consistent today and tomorrow. If there's one compound, it's a decomposition. So how will this break down? Na plus Cl2. Because it's, what is that called again? Chlorine. By itself, it's chlorine. Here it's chloride. Okay. So ide, not diatomic. We let charges determine. Chlorine ends in INE. Okay. So are we balanced? 2 there. And 2 there. Very good. Sound good? And we got one more. How do I write this? Good. Ca plus YO2. Gen, ends in gen. Good. So these synthesis and decompositions are tough, aren't they? Don't make them harder than they need to be. And then, so calcium looks good. How many oxygens do I have? So put a 2 there. Then what? 2 there. Okay. Yeah. Okay. All right. So, mercy. So today, again, the first. Whoops. Come on now. Scroll. There we go. So the first part is. This is still homework here, so good practice. Apologize that I didn't give you a whole lot of room there. But you don't need a whole lot of room for these bottom ones, so you can use the space there. And you got unlimited space to the right. Okay, so do both sides. I'm sorry, this used to be one piece of paper. And then over here, even though I don't have the line over here, tell me what type of reaction you have. Okay? Because on the test, what we'll do is, not this Friday, but next Friday, I'll give you equations, and you balance them out, you predict the products, and tell me what type of reaction it is. Sound good? All right.